Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing this morning will be the actual voltage output coming from the secondary of this power transformer here. Because what I did, guys, is that I tried to assemble a rectifier circuit. I tried to assemble a rectifier circuit to rectify alternating current to direct current. The input on the primary is alternating current, and on the secondary side, it got 10 terminals, and there are actually 9 output voltages that could be taken from this AC voltages. So if there are AC voltages here, okay, what is only needed now is actually a diode circuit to rectify this alternating current. So we could use the output of the secondary in terms of direct current value, and the needed component are actually this one here. We got a bridge rectifier diode here. We got an electrolytic capacitor. So I assembled this one a while ago. This terminal here is actually the AC input to the diode, these 2 terminals. That's the AC input to the diode. The output of the diode is actually this red and black. So if we try to measure the voltages on this red and black, it will now be a direct current. To show you the diagram of this one, this will be the diagram of the bridge diode. We got line number 1, line number 2, okay. This is a symbol for alternating current. This is a symbol for alternating current. Meaning to say, if we try to connect our line number 1 and number 2, it will be on the AC line. And the output voltage for this bridge diode will be coming out from the plus and minus side. So in here, the 2 middle terminals is with the designation alternating current. Okay, so this is alternating, and the plus side of the diode will be this side here, the red one, and the negative side will be this black one. Okay, so this is the AC line, this is the DC voltage output, and to filter out the pulsations, I connected an electrolytic capacitor between the plus and minus to rectify, to smoothen the pulsating DC on the secondary. Okay, and the voltage, the value of this electrolytic capacitor is 220 microfarad, 250 volts. I bring out one of my electrolytic capacitors, and I make sure that the voltage will be high enough so it could accommodate the maximum voltage that will be coming out here. So if the maximum voltage that could be taken by this electrolytic is 250, if the maximum AC voltage here is just 50, okay, there's a little bit of factor of safety by using this electrolytic capacitor. So if I will try to go to the 12 volts, this 250 will be fine. If I will go to the 30 volts, this electrolytic will still be fine because the voltage of this one is 250. If I will go with the 50 volts, I could still use this one. I don't have to change the electrolytic because the voltage of this one is 250. So for this 250 here, if I will try to change the tapping, okay, I could use this 250 volts capacitor that it will not be affected by the voltage, okay? The voltage on this is lower than this 250, so this is fine, okay? So this is the rectifier circuit needed to be connected on the secondary to bring out a DC voltage, okay? Okay, I will now try to connect the AC line. This is the AC line. The AC line is this one here, the yellow and white. So I will try to bring out the voltage between 3 and 9. Okay, so I will connect AC line to terminal number 3. Okay, and the other AC line will be terminal number 9. 3 and 9. 3 and 9, the voltage should be, the AC voltage is 29.6, but if we try to rectify this one, this should be greater than 29.6 because it's not regulated, right? It will go beyond 29.6. And I will try to connect the plus terminal on my multitester and the negative terminal on my multitester. And I will set the multitester to DC voltage so it will read DC voltage. Could you see it, guys? So we could read the voltage. So what I will do is that I will try to rectify the AC voltage between terminal 3 and 9, and according to my previous blog, I have computed that the voltage is 29.6, but if we try to rectify this one, the voltage should be greater than 29.6. Okay? So the AC line is now connected between terminals 3 and 9, and the output is connected to the DC voltmeter. This is now set to DC voltage. So if I will try to plug in the primary here, we should be getting a voltage greater than 29.6. Okay. Okay, I will switch on. Okay. So as you could see, guys, the voltage, DC voltage is 40.9. 40.9. This is 29.6 voltage AC. This is 29.6 volts AC. If we try to rectify this one by using a bridge diode, the voltage output is 40.9 volts DC. Could you see it, guys? It's 40.9. Okay, 40.9. So this is a good thing, right? I will try to go to terminal 4 and 5. I will try to remove first this one. Okay, I will go to terminal 4 and 5. This is the AC line is on terminal 4. The other AC line will be on terminal number 5. Correct. 1, 2, 3, 4, 5. Okay. And according to my previous blog, terminals 3 and 9, is it 3 and 9? 4 and 5. The voltage, the AC voltage here is 12.56. But if we try to rectify this by using a bridge diode, the voltage should be greater than 12.56. Okay, I will try to plug in. I short out the DC voltage because we are not consuming the voltage that was brought out a while ago. So this is now almost zero. So we'll go to terminal 4 and 5. I short out the voltage because we are not consuming the voltage that came out a while ago. So it's almost zero. Yeah, that's zero now. Okay, zero DC voltage. Like what I said, if I connect terminals 4 and 5, the voltage AC is actually 12.56. And if we now try to rectify this one, the voltage should be greater than 12.56. Okay? What comes out is 16.85 volts. Could you see it, guys? That is 16.85 volts DC. Okay? That's terminal 4 and 5. This is a rectified DC voltage already. Okay? What's the next one? I will try to remove this one. Okay? This voltage here is not yet used. So if we try to go to the other terminals, we must have to short this one. Okay? So it will become zero. I short it out. It's zero. Because there was an energy a while ago and we are not consuming it. So if we try to measure the other voltages, we should set that one to zero. Okay, let's go to terminal number 8 and 10. I will connect the AC lines to terminal 8 and the other AC terminal will be terminal number 10. Okay, and according to the voltage that was measured a long time ago on my previous blog, the voltage between 8 and 10 is actually 59.2 volts. Okay, so if we try to rectify this one, we will be getting a voltage greater than 59.2 volts AC. Okay, I will try to plug this one now. And what comes out is 82.5 volts DC. Okay, that's 82.5 volts DC. Okay, that's a very big voltage. DC voltage 82.6 volts. So we just don't touch the DC terminal. That's 80 volts. Okay, you'll get electrocuted. You might get a little shock. It's 80 volts, right, guys? I will go to terminal number the one with the laser value, so we could operate an electric fan. I will try to short out this one. Okay, the voltage is still intact. That's 80 volts. Okay, we short it out. So we'll go to terminals, terminal number 1 and 2. Terminal 1 and 2. The AC line will be connected to terminal 1 and 2. And from my previous blog, I measured the AC voltage of this one to be 3.6 volts. So if we try to rectify this 3.6 volts, the value should be greater than 3.6. Okay? It's 4.26. 4.26. Okay. I will try to remove this one. I'll try to remove the tester here. I'll try to bring out my what do you call this DC electric fan. So what will I do? I will try to connect the plus on the plus. It will try to operate this electric fan, but it's not so fast because the requirement of this one is actually 12 volts. Okay. Okay, I will try to plug in this one. The voltage is too low for it to operate. Okay. We'll go to terminal 6 and 7. We'll go to terminal 6 and 7. Okay. We'll try to measure the voltage first before we will operate the electric fan. I will pull it and voltage DC. The one with the least value here is 6 and 7. We'll connect the AC line to number 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then the other AC line will be terminal number 7. 7, 8, 9, 10. Yeah. Right? We'll try to plug in this one. The voltage is 13.66 volts. I think we could operate the electric fan maybe. So I will try to remove this one. Okay. I will connect the plus side to the plus terminal of the electric fan, the negative terminal to the negative terminal of the electric fan. Right? Then I will try to plug in this one. So it works. Okay? It works. So by using terminal 6 and 7, it got an AC volts of 10.3 volts AC here. And when we rectify it by using the bridge diode, like what we measured a while ago, is 12.56. So it operates our electric fan. Okay? So by using this power transformer here, and by using one of the terminals, and by using the bridge diode and this electrolytic capacitor, we could operate this DC electric fan here. That's the so-called advantage of knowing and how to bring out DC voltage from an available AC voltage. Could you see it, guys? The DC electric fan is now operating by using the connection terminal 6 and 7 on the AC line. Okay? And what comes out on the DC voltage as we measured a while ago is 12.56. Okay? And since the DC fan is actually rated 12 volts, 12.56 is just not more than, it's good enough for it, right? It will not be burned. The requirement of this is 12 volts, but if we go beyond, not so much, it will still be fine, not burning it. So by using terminal 6 and 7, we could operate this DC electric fan. Okay, that's it, guys. That's how I bring out the required DC voltage coming from this power transformer by constructing a bridge diode with an electrolytic capacitor. Okay? And I make sure that the electrolytic capacitor, the voltage should be greater than the AC voltages that is available here. Because the voltage of the electrolytic capacitor is 250, and the highest voltage that we have measured here a while ago is just 80. So this is verified. So no matter what terminal we will be using here, this electrolytic capacitor will still be used. So I tried to use an electrolytic in which the voltage is greater than the available AC voltages on the secondary. Okay, that's it guys. That's how I bring out a DC voltage coming from a power transformer by using my assembled bridge diode plus electrolytic capacitor. Good morning from Los Angeles. This is Professor David J. De Los Reyes.